Hello, it's Keith here, and this is lesson 7 of the Suck series of my assembly program tutorials. We're looking at Suck on the Z80 again, and you can see the Amstrad CPC version starting up there. This is my little game that's a parody of Duck Hunt and Operation Wolf, basically. Today we're going to be going over some of the code that handles the sprites. We're going to be looking at the code that handles the sprite movement and detects when a sprite is going to hurt the player and things like that. The game is of course 3D, and that's very relevant. You can see the game running up there. The moon is moving across the screen, and the moon is actually the level time when the moon gets to the edge of a screen. In this case, that edge, on the next level it will reverse. The level has ended now. You can see there's some bats on the screen and they're getting closer to the screen, and when they become in the foreground they will actually start to hurt the player and take life from the life bar at the bottom of the screen. So we're going to see a lot of that in action today in our code. We're going to be discussing that, and let's go over now and let's take a look at that source code. Okay, so we're going to be going over the animate sprite routine today, which handles all of the updates to the sprites of the enemies and the other objects on the screen. Now, the game ticks are very fast. The game is moving quite fast with regards to things like detecting the fire and the moving of the cursor, but the actual objects don't move so fast. So first of all, what we're doing is we're taking the game tick and we're ANDing that with the game speed so that we don't update the sprite movement every single tick. Now, the game gets faster in the harder levels later on in the game, but at the start it's very slow. And what we're doing there is if the game tick doesn't need updating, then we are returning. And then next what we're doing is we're checking the animation tick of the object. Because game ticks aside, we also have the fact that some sprites move faster than others. So we're checking the animation of the current sprite. The sprite is being pointed to by IY during this routine. That's the case with all of the code. We always point IY to the start of the object's definition. What we do after we've checked the animation tick is we check if the sprite is even alive. We check the bit 7 of the program code, and this defines if the sprite is dead or not. And if the sprite is dead, then we're going to jump down to animate dead sprite, and that will handle the dead objects. Okay, so we've got a sprite that we want to actually update. So what we're doing next is we're removing the old sprite from the screen, and we are using XOR sprites. So we just use draw sprite from IY, which draws it in the same position, and that effectively removes it. On the Sega Master System, we need to reconfigure the graphics routines a little bit because the Master System can't do XOR, which is a pain, but it can't. We're then updating the tick of the current sprite, and this handles how the sprite's animation will work, so that will update potentially the animation, so that we do that. We then run update sprite from IY. This recalculates the currently shown sprite object for the frames of animation, and if necessary updating the size of the sprite if the animation frame has changed. We're then getting the object type here from the program, and this defines the type of object that is being drawn. The different objects, you know, a rock is different from a bat, for example, and that's all defined by the program. Now, what we're doing here is we're seeing if the current object is a Chibico. That's the mascot. You can see it down there. It's the vampire bat character, and so that is the boss effectively in this game. And what it does is it moves around the screen in a zigzag pattern in 3 dimensions. And what I mean by this is it will move in all 3 directions, and when it gets to the edge of the screen, either the top, bottom, left, right, or foreground or background, it will reverse its movement in that direction. So it's constantly bouncing around the screen, if you will. And so that's what we're doing here. We're taking the Y position, we're checking if we're at the top or the bottom of the screen, and if we are, we're flipping the Y movement. Then we're checking X position, seeing if we're at the left or the right of the screen, and if we are, we're flipping the movement. And then we're checking the Z position, the 3-dimensionality, and we're flipping the Z position accordingly. Okay, so that's handling our Chibico character, and that's the end of the routines that process the Chibico character. The rest of the code that does that is the same as the regular bats. So the code that hurts the player isn't affected. It's just the movement's very complex for that character. So what we're doing next is we're updating the X position, and we're then checking if the sprite has gone off the sides of the screen. Now, originally the bats were going to move horizontally. I decided that wasn't appropriate, so I took that out, but originally that was how it's going to work. So this code now really only applies to objects like rocks or clouds, or the power-ups that the player can collect. So we check if they've gone off the screen, and the off-screen routine basically reinitializes an object that has either been killed or left the screen of natural causes, so to speak. So That we'll see in a moment. And then what we're doing next is, again, we're checking for another special kind of object, and we're looking at the moon. The moon is effectively the time remaining in the level. If the moon moves very slowly, the level's very long. If the moon moves super fast, the level will be very, very quick. So the moon effectively is the level time. So we're checking the X position of the moon here, and we're seeing if it's at the far left or the far right of the screen. We have to check both because the moon alternates its direction depending on the level. So that's why we're doing that. If the level has ended, we're just clearing down the stack, resetting the stack pointer, applying some bonus score for the level ending, and we're incrementing the level number and restarting a new level there. That's what we're doing. If we get here, then we aren't dealing with the moon, we're dealing with another kind of object. So we're now updating the Y position, that's vertical, and the Z position, which is in and out. So we're updating all three there, and we're just checking the Z position of the object. Now, if the object is in the foreground, that's like this kind of area here, quite close to the player and sticking out of the screen visually, then we're going to want to hurt the player. And so what we're doing here is we are checking the level number, and we are setting the tick rate accordingly, and that's because the enemies will hurt more in the later levels. The game gets progressively harder. So we're then checking if we want to hurt the player this tick, and if we do, then we're going to jump to one of the modules depending on the kind of enemy, and there are 4 kinds of enemy in the game. There is the Corona enemy, there's the Chibico enemy, and there's the basic bat and the Gobby bat, as they're called. The Gobby bat's got a bigger mouth. Now actually all 3 of the bat characters, Chibico and the 2 bats, they all hurt the player in the same way. It's only the Corona character that it hurts less, and the reason for that is the Corona character immediately appears in the foreground, so always hurts, but hurts less as a sort of balancing. So what we're doing here is we're setting the amount of life to take away here. We're taking 64 or 32. Now these are fractions of a life bar unit. The life bar at the bottom, each of those blocks is effectively 256 fractional units. So here we're basically taking 1/4 of a unit, and here we're taking 1/8 of a unit. So that's how that's working, and we are effectively doing that here. We are subtracting the partial unit here, and then if we've completely removed a unit, we're actually running the removal function here, and we're making the beeping sound to warn the player that they are being hurt here, so that they know to actually get their finger out and start trying to shoot them bats. So that's what we're doing there. At this point, we've actually finished updating the sprite, so we now set the draw routine back to normal on the master system without its XOR, and then we show the new sprite position to the screen. Okay, so that's how we're drawing the sprite. We're now just going to quickly discuss the off-screen routines. Now, when a sprite is dead, it's not drawn to the screen, but all of the objects in the game, whether it's an enemy or a piece of background or a power-up, they all come back at a later point. And we use a respawn time for that, and we actually reuse the life counter. The life counter would typically be how much health that enemy still has, but when an object is dead, the life is actually the amount of time till it comes back. So what we're going to do is, depending on the kind of object that has disappeared, either a bat or a Corona or a Chibico or a power-up or any of the random background, we're going to set the random time until it comes back, and we're using the set life function with a maximum minimum range depending on each kind of thing. Now the background we have come back super fast because we want the background to look nice and busy, so our game looks quite impressive. The power-ups we want to delay a little bit because we don't want the player to get too many power-ups. The Chibicos basically never come back. They don't really come back at all. The Coronas, they come back pretty much straight away. They're very, very fast, and the enemies are pretty fast too. So we can make the different kinds of enemy behave in a different way just by tweaking these to make the game a bit different. You know, if we wanted more Coronas and less bats, we can configure that, and if we want more bats and no Coronas, we can configure that too. So this is just part of the code that defines how the game feels and how the different enemies will have a different characteristic in the game. So there we go. So that's all we're going to be looking at today. A little bit of a short lesson maybe, but the animate dead sprite code, which handles the respawning is enormous. So I couldn't really go over that in the same lesson here. Anyway, as I always say, you can go to my website, you can download the Suck game in source code and compiled code for free, and as I say every time, you're welcome to do whatever you want with the source code. It's free, it's open source, you can take it apart, you can use the code in your own commercial projects. Good luck to you if you somehow manage to do that. But really, I just hope that by showing you the code in this way, you get some ideas of how to make your own games that work in a similar way. Not necessarily saying my code is particularly a good way of doing things, just that it works to the extent I've shown today, so hopefully it might be some use to you. Anyway, if you're interested and you want to support my channel, I have written a book. It's Learn Multi-Platform Assembly with Chibi Akamas, and it covers Z80, 6502, 68000, 8086 in ARM, and you can get it from Amazon either as a printed book or as Kindle if that's what you like, so please go ahead and do that. Anyway, I hope you've enjoyed this. Thanks for watching today, and goodbye.